Hey, welcome back. We're in the middle of our solve one-step addition and subtraction equations lessons. We are on example 4. So we have gone through the following. We talked about what an equation is, solution, equivalent equation. We used the subtraction property of equality. Now we're going to use the addition property of equality, and basically what that property is stating that if you add a number or a variable to both sides, it's the same thing to both sides of an equation, it's going to stay equal. And that's important in an equation because that's what an equation is, two quantities that are equal. So in example number 4, we have x minus 2 is equal to 1. So first thing we're going to do, same thing we did before, is you're going to draw your line so that we can show our work. And then when this time, though, to get to isolating the x, or getting the x by itself, you have to remember that our answer is going to look like x is equal to a number, okay, or a value. So to get that x by itself, we're going to use the addition property this time. And if you think about it, this is a negative 2. I want to get that to 0. Well, let's add 2. Okay, once I do that, that zeroes it out. And you do the same thing. The addition property tells me we have to add 2 to both sides, and then that gives me 3. So my x should equal 3. That should be the solution. But we're going to test it. And by testing it, we're just going to take our 3, place it back in for x. So instead of x, it's 3 minus 2 equals 1. Well, that's true. So therefore, x is equal to 3. So the only difference in this example versus the other example is that now we're adding on both sides, and usually it's because we had a negative 2, we're getting it to 0. So if you add 2, you get to 0. Negative 2 plus 2 is 0, and then you add the 2 to both sides. Okay, go ahead and try these two. I'll give you a hint. You're going to be adding to both sides. Okay, you should have answered those two questions. Let's move on. A pair of shoes cost $25. This is $14 less than the cost of a pair of jeans. Find the cost of jeans. Okay, so a couple of things here. First thing is words. We're looking at our words. Shoes are $14 less than jeans. Let J represent the cost of the jeans. So you can see they don't, when we talk about variables, jeans starts with a J, so they just go with J. You could choose X if you want to. That's perfectly fine. Okay, so when we look at our models over here, we see that the jeans is this full piece right here, from here to here. But my shoes are less of that, from here to here. But if I take 25 plus 14, okay, if I add those, what I have here is I have my jeans. Okay, so the way it's going to work is that we have a pair of shoes cost $25. This is $14 less than the cost of a pair of jeans. Okay, so when we look at this, we need to say, okay, this is one side. This is one side, and we see that the shoes are 25, and then the other side is that our jeans are going to be 25 plus the 14. So how are we going to write this as an equation? Okay, we definitely can write it this way here. Okay, or if we wanted to add on both sides, the addition property on both sides, we can also make it to where it's 25 is equal to j minus 14. So our thinking on this is that our jeans less than 14 is equal to the cost of the shoes. And that's basically what it says. A pair of shoes cost $25. This is 14 less than the cost of jeans. Okay, well, minus 14. Jeans minus 14, that's 14 less. And then you just go ahead and you start solving it. Plus 14 on both sides. Don't forget to draw your line. Plus 14 on both sides. Okay, that zeroes out. 25 plus 14, that's going to give me 39. So now my jeans are going to cost $39. What does that mean? Well, that means my jeans are $14 less, or my shoes are $14 less than a pair of jeans. That's kind of how we did it. So my shoes are $14 less than a pair of jeans. So what do I need to do? You add these up, that's the pair of jeans. So that's kind of how the model works. Let's try one out on your own.